kita akan mulakan kelas. Sementara nak tunggu semua masuk, mungkin ada yang share dengan kawan-kawan, maksudnya share screen dengan kawan-kawan, so it doesn't matter. Alright, so first of all, I would like to welcome you all to Pusat Asasi. So right now we are in PHY 094, Foundation Physics 1, okay, Foundation Physics 1. And inshallah I will share everything. I'll try my best to lead and to guide you all. For the rest of, I think I will only handle your class at least until week 4, okay, and then afterwards you'll be transferred to another lecturer. But doesn't matter, the work still work. We need to continue whatever we have been asked to do. Okay, so right now, okay, boleh dengar suara saya dengan jelas? Everybody?
Boleh saya.
Okay, great. Okay, mungkin ada input daripada girls, daripada pihak perempuan ada? Saya dengar pada pihak lelaki je. Perempuan dengar ke? Okay. Is it okay?
Okay, sir.
Okay, great. Alhamdulillah. Alright, so first of all, thank you very much. In a short notice, kita terpaksa gather dalam situasi virtual because of unexpected. So I would like to, I really want to go to your class, but right now I'm still in the quarantine mode because of my son. So but doesn't matter. Okay, we still work. Okay, we still can continue our class, right? Okay, so now our class is on Thursday. Okay, Thursday 2 to 4. Okay, masa yang sangat tak kondusif untuk belajar fizik. 2 jam di sebelah petang. But we will have 1 hour class tomorrow. Still, okay. I'm still in the quarantine mode, so we'll still continue our class using this virtual at least until this week. Okay, and then next week we'll try to look at back how can we proceed with our class. Okay, so let me share the slide first. Okay. As a introduction to our class, so let me share the slide. Okay, can you see the slide?
Yes,
okay, great. Okay, so welcome to Pusat Asasi. This is Sun Center of Foundation Physics, right? So this is our book. Okay, for PHY 094, we will use this textbook. Okay, what we call as a college physics survey, the 11 editions. And if you look on the left side, okay, the lecture started this week at the 31st July, okay, and then it will continue to 26th of November 2023. And then we will have some midterm tests on the 18th of September. Okay, please take note. Okay, the midterm will be on the 18th of September 2023. Okay. The class tak start lagi, saya dah mention mengenai midterm peperiksaan pertengahan semester. Okay, so then you will go to your midterm break after the midterm test, about 1 week, and then we will continue back with our class with in week 8 until week 14. Okay. And of course, the public holiday National Day will be on the 31st of August 2023. I think during that time, if I'm not mistaken, the 31st August is on a Thursday, so that will affect our class. So maybe on that particular week, okay, we will continue. We will do our class with virtual mode, right? So doesn't matter, okay. And then if you want to purchase this book, okay, you can have the link. The ababookstore.com, and that link will show how to order, right? So, okay, this is some academic calendars for your session 2023-2024 for Asasi program, right? So again, I would like to emphasize on the kuliah 1, the lecture 1, and also the lecture 2 that will took about 7 weeks. Okay, 7 weeks in the first mode before you go to midterm break, and then the and followed by a break, and then another week after the break will be the 7 week, which means on week 8 and until week 14. Okay, so there will be a study week. Okay, and then we will go to the final on the 27th of November. So please take note on this date. Okay. All right, so let's continue. Okay, so if you look at the academic calendars, okay, it stated that on the 31st July until the 30th of August 2023, okay, there's a process entrance survey. That's what we call that as a entrance exit survey. So you need to answer some entrance survey. Okay, that means when there is an entrance, so there must be an exit survey. So we will give you like about 2 or 2 weeks time. In 2 weeks time, you need to answer the entrance survey in the near future. Okay, I believe that you have been told that you have been to take the survey on the entrance survey in the future by your head of program. So for the first and second week of study, so that means you need to do some entrance survey. Entrance survey ni, okay, in short term, is like apa yang awak akan belajar, apa yang awak akan tahu sebelum awak masuk this course. Okay, katalah course ini course physics PH1 094 A094. So sebelum masuk, adakah awak dah tahu dah course ni? So mestilah jawapan dia banyak yang awak tak tahu. Then after exit barulah awak boleh jawab, okay, selepas dah belajar barulah dah tahu. So itu ya, jangan main jawab saja. So very important for you to understand this entrance and exit survey. So entrance, that means you have nothing in knowledge about physics or about the course, but when you study the course and then the result is on the exit survey, you can at least know apa-apa yang berlaku kita dalam course kita tu. Okay, so maksudnya of course sebelum belajar tak faham, lepas belajar faham. So belajar faham tak faham tu itu depends lah kan, tetapi proses ni macam tu so jangan ambil mudah survey ni, tapi jangan lupa masa dia hanya 2 weeks time, hanya ada 2 minggu saja, right? So the exit survey will be appeared online in the week 14 of study. See, the exit survey will be put on the week 14. Okay, week 14. So on the week 1 until week 2, you must answer the entrance survey, while the exit survey will be appeared online in week 14. Okay, all right. It will only take about 5 to 10 minutes to answer the survey. So please, all right. So you can log into your future here to answer the entrance and exit survey. Please do it afterwards. Okay, when we finish the class. Okay, so you need to answer the entrance survey. Okay. So this is some introduction to our courses. Okay. So PHY 094 is a foundation physics 1. All right. So the course outcome for this course will be CLO1 until CLO4. We have a CLO1 until CLO4. Okay. What is CLO1? CLO stands for course learning outcome. Okay, course learning outcome number 1 until course learning outcome number 4. So for the course outcome, maybe for physics students, okay, we will choose a CLO1 until CLO4. Maybe for the other course, let's say chemistry or biology, it took another CLO. Okay, so based on that, okay, I believe that you have been you have met your lab instructor that also have briefed you, give you some briefing about course outcome for financial physics 1 in terms of laboratory that will use a CLO number 2 and CLO number 3. Okay, but for the whole course, okay, the CLO will be CLO 1 until CLO 4. Right? So what is it? Okay, you can read it on your own. What is CLO 1 until CLO 4? Okay, but in short, or in how can I just give you some a short brief about what is CLO 1 until CLO 4 for physics students. So is it when we talk about CLO 1 and CLO until CLO 4, it gives you some what we call as the skills that you need to get the course in our or so we can map it in terms of what can we pursue afterwards. Okay, so the learning outcome number 1 until number 2 and number 3 and number 4 will give you. Okay, let's look at the CLO number 1, basic knowledge. CLO number 2, basic practical skills. Number 3, leadership, and number 4, the entrepreneur mindset. So all of these CLO will contribute some continuous marks. So that's why when we talk about continuous marks markah yang kita akan kumpul before we go to final is based on this CLO. Okay. So this is the syllabus and the tentative. Okay, syllabus and the tentative, right? So right, this is some learning outcomes. So if you look at the lesson plan, this is what we call as lesson plan. Okay, on the left side, the very left side, you can have a week. Okay, week number 1 until week number 14. So when you took or when you read a lesson plan, you should everybody should have their own lesson plan, because you must always base on this lesson plan, right? Because in week 1, what can we study? What is the topic that we can learn, right? So what is the topic? For example, we have a 1.0 physical quantities and units. Okay, so what is 1.0 in our lesson plan can or mirror to whatever we can learn in the textbook. So based on the textbook, okay, the chapter that we should learn for topics 1.0 will be 1.1 until 1.6 without 1.2. Okay, so 1.2 will be put somewhere else. All right, so we can learn these topics in 3 hours. Okay, so this is how we look at the lesson plan. And then of course, every lesson plan you should map with, or you should look at the learning outcomes. Whatever the outcomes from each topic will be stated here. Okay, for example, the basic quantities and SI units, you can study about the state. So you can state basic quantities and their respective SI units. Okay, state derived quantities until all the learning outcomes achieved. So that is how we know what is the topic learned for this week and what is the learning outcome. Of course, all topics must always come with the learning outcomes. Okay, so this is all the topics that we should learn this week. Okay, from 1.0, 1.1 topics and until 1.2, scalars and vectors. Okay. Do you have any questions so far? Ada soalan? Boleh tanya terus kalau ada apa-apa nak tanya. Tak ada? Okay. So based on our CLO, Okay, this is the assessment. Okay, the continuous assessment, the coursework marks that contribute by the CLO. So we can assume that, right, for 100% marks for final PHY 094, 50% comes from the final examinations, and another 50% will be based on this coursework. Okay, that means it comes from tests, not 20%, lab work about 20%, and also another 10% will be from the entrepreneur mindset assignment. Okay, so 20 plus 10 equals to 50. So the 50%, before you come to the final examination, you already have 50%. Okay, so another 50% comes from final. So that's why you need to come to final examination. If you, let's say, alhamdulillah, you can score 50 marks for the coursework, you still need another 50 marks because the passing mark in your ITM will be 50 marks. Okay, itu passing mark, right? 50. Kalau bawah pada 50, fail. Right? So that's why you need to at least come to final examination, must come to the final examination in order to get another 50 marks. Okay, and again, the recommended textbook will be Survey, College Physics 11 editions. What if you do have a College Physics another edition, you still can use it. Okay, no problem. Okay, it is advisable for you to get one textbook for your own, because from that textbook you can look and you can do a lot of things such as tutorials whatsoever. Okay, so other references that can be used also is Walker, Giancarlo, and so on. Okay, there is other references, but it's not our textbook. Our textbook will be based on Raymond survey. Okay, that means if anything's related to, let's say, if we're discussing about meanings, okay, ada beri pengertian, contoh dia force. So other books can also describe about force, but we took the correct or the accurate meanings of force using our textbook. So that's why you need to get our textbook. Okay, at least you can have this textbook by maybe you can get it from your seniors. Okay, if they still have it. All right. Okay, never mind. Okay, so this is some entrepreneurial mindset assignment that contribute to 10%. So you need to discuss with your tutor how to when is the date to submit the entrepreneur mindset assignment. Okay, basically it's at the end of the semesters. Okay, so what is entrepreneur mindset assignment? Then you can discuss with your tutor. Okay, so this is the grading scale in physics and your ITM, of course. Okay, so the passing mark will be C. That means you must get 50 marks to pass. Okay, the red one will be failing, right? And of course, from 80 to 100 will be considered as A. Okay, there is some a small margin in terms of A minus and B plus, which means A minus is from 75 to 79. What if you get 79.5? 79.5 can be round off as 80. So 79.5 is considered to be A. How about 74.4? 74.4 is still 74. That means the grade will be B plus. Okay, so you should know the difference that can easily influence your CGPA. Okay. Okay, so this is some samples. Okay, any questions so far? Ada soalan?
Tak ada, sir.
Yeah, all right. Okay, so let's continue to our lesson. Okay, let's continue to our lesson. Right, kita akan teruskan dengan kita punya ni. But before that, kalau ada soalan, please, okay, boleh tanya terus ya. Let me share the slide. Okay. Before we start, let me share some slide about a cost and yeah. Okay. These are some example about the entrance exit survey. Okay, so this is the entrance survey. All right. So let's look at the CO1, the cost outcome. CO means cost outcome. So number one, I can state 3 Newton's law correctly. Okay, this is the entrance survey. Okay, can you state 3 Newton's law correctly? I believe that all of you can. Okay, but for the sake of is it an entrance and exit survey? So at least don't put a lot of don't give high marks in terms of entrance. Okay, at the entrance you should at least be polite, okay, ataupun lebih be humble lah. Okay, walaupun tahu tapi tak adalah letak markah terlalu tinggi sebab letaklah markah rendah and then bila dah dekat exit survey nanti of course you already learn about these 3 Newton's law. Barulah kita letak tinggi. So nanti dia akan ada gradually because this one is really help us in order to maintain the cost. Maybe in the future kan your kids or your apa adik-adik nak belajar ke asasi, okay, ni memerlukan benda ini untuk kita stay relevant dengan this kind of things. Okay, so that's why you need to answer it correctly. Jangan main hentam saja untuk jawab soalan-soalan ni ya. Kalau rasa tak boleh dah, tak faham lah, letak saja rendah, letak saja tak faham. Okay, but on the exit survey you can put yang higher daripada yang you buat asal dia. Barulah ada apa masalah dan penyelesaian. So that's how, this is what I mean by entrance and exit survey. Okay, right, so let's stop sharing. Okay, okay, so this is how you can order, pay and pick up at kedai number 28 from the ABA bookstore. Okay, so at the Anjuran K, you can buy the textbook from here or at operating hours, this kind of operating hours. Okay, Monday to Thursday, 10 p.m. to 3 p.m. and on Friday is 10 a.m. to 12 p.m. So on Friday only about 2 hours and close on public holiday and weekends. Okay, so this is Anjuran K on the second floor. All right, so you can take the number and you can pay. You can order first, pay and pick up the textbook. Okay, if you want to buy the textbook. Okay, that is not compulsory about textbook. Okay, and of course, before we start, okay, I would like to remind all of you, the lecture, the attendance to the lecture is a compulsory. If you can come to the class, okay, our physical class, of course, if you can come to the class, okay, please acknowledge your lecturer or your tutor at least, or else you can tell your friends or your class rep, okay, because everything will be count as the attendance, okay. So like today, I think, okay, lebih kurang lah hari ni ya, sebab kita berada di virtual, okay. But I still can have all of you. I can still get the attendance from all of you in Microsoft Teams. Okay. Okay, so let's continue to our lesson. Okay. Without further ado, I want to share the screen. Okay. Can you see the slide, everyone? Boleh nampak?
Yes, sir.
All right, cool. Thank you. Okay. So this is the Foundation Physics 1 as an introduction. Okay. Ini kita nak masuk. I will share the slide. Okay, I will share the slide with your class rep afterwards, and the class rep will give you the slide to all of you. Okay, no problems. All right. So in this chapter, okay, we will learn about standard of length, mass, and time. Okay, standard of length, mass, and time. Okay, the dimensional analysis, right? The uncertainty in measurement and significant figures, the conversions of units, and the estimations, right? So this is units of chapter 1. All right. Okay, let's look at the 5 base quantities with units, right? Again, this is something that you have learned during your school days about 5 base quantities. Okay, 5 base quantities, right? So we start with the length, mass, time. Okay, length, mass, time, temperature, and current. Length, mass, and time, temperature, and current. Okay, I'm using a different symbols to represent what? Okay, these 3 LMT is very significant in this semesters. Okay, but for the temperature and current, again, we will learn later, at least until week 13 or week 14 about temperature. But the current, we will learn in a different semester. So in the semester 2, we will learn about current. But we will focus on these 3 LMT system, right? But in physics, the 5 base quantities still, you need to know about length, mass, time, temperature, current. Length is panjang, mass is jisim, time, masa, temperature ialah suhu, dan current ialah arus. Okay, kita baca electricity, we will learn about current. So now in the middle part is the symbols, okay, with the SI unit, standard units, and the symbols for the units. Okay, so maybe we can write down as length, for example, length with L and the unit in meter. This is how we write. Sorry, this is how we write it as length LM. Okay, panjang ialah L in the bracket will be the units meter. Okay, the SI unit for length is meter, not centimeter. Okay, not kilometer. So it's a meter. The SI unit for mass will be kilogram. Okay, so just a quick revise. Okay, a kilogram with the symbols kg. Okay, and the time, the SI unit for time will be second. If the question gives you millisecond, that is not the SI unit. So you need to convert it to second. And of course, The small letter S is the symbols for its units. And of course, the temperature is not Celsius. Okay, the SI units for temperature will be Kelvin, and with the capital K as the symbols of its unit. And the current will be ampere. Okay, ampere, not milliampere. And of course, the symbol will be A. All right. So from that 5 basic quantities, we can derive another a lot of derived quantities. So this list of 5, at least 5 derived quantities based on basic quantities. Okay, so let's look at one example. Let's say if you took velocity, halaju, velocity. The symbols for velocity is V. Okay, the SI units for velocity, what is the velocity? Velocity is halaju. How to get velocity is based on speed over time. Speed over length over time. Okay, length over time. Okay, how can we know about length over time? Of course, okay, bila kita ada panjang dibagikan dengan masa, then we will get speed. Okay, speed ataupun velocity. Beza kan, speed dengan velocity, because velocity is a vector quantity, while speed is a scalar quantity. Okay, so the SI unit for velocity will be meter per second. How can we know meter per second? Because the velocity itself comes from length over time. What is the length? Length is L and time is T. Okay, based on this one, L and T. So we will get length over time, and the unit, okay, length is meter and time is second. This is how we know the velocity, or the units for velocity will be meter per second. Okay, so this is the units. One star is the units. Okay, so of course the acceleration is a meter per second. Meter. Okay, the acceleration is actually V over T. What is V? V is velocity. Velocity is what? Meter per second per second. Okay, so meter per second. So that's why we get meter per second square. Okay, as the units. Okay, and then of course let's come okay, the force. Okay, the SI unit will be Newton. Okay, force will be Newton. Or what is Newton? Because we know that force comes from a kgm over s square. Kgm over m square. Kgm over s square. Okay, what is kgm over s square? Kg is what? Kg is mass. Okay, mass. This is mass, and meter per second square is acceleration. That is how we get mass times acceleration. So we get force. Okay, kgm over s square. So F equals to ma, mass times acceleration. Right. So momentum is the Newton second, or kgms, m over s, and the energy will be joule. You look at the Newton joule. Okay, momentum, of course, Newton second. Okay, this is how we derive from the basic quantities. Okay, ada orang yang tak faham macam mana nak dapatkan basic quantities ni. So don't take it slide. You need to know details right now. Okay, jangan anggap dia benda yang biasa. Okay. So look at the approximate values of some measured length. Okay, approximate values. This is something about values that we only use it as an approximation, in the approximation. Okay, we can never know about the details or the exact value of the measured length. Okay, for example, the distance from Earth to most remote node in known quasar, the distance between Earth and Moon, Earth to Moon, Earth about Sun, the orbit, everything is here is what we call as approximation. In terms of approximation, we can only know about approximation because it's very impossible to get the exact value. Okay, all right. Okay, this is some approximation values of some masses. For example, a mass of a sun, a mass of moon, a mass of mosquito. Okay, a very big things until the very small things. Okay, and this is some approximate values for some time intervals. Okay, the sum for some time intervals about let's say the age of universe, age of Earth, durations of nuclear collisions, and so on. Okay, now let's move to the very interesting part in terms of prefix. Okay, prefix. Ini kita belajar kan dulu masa sekolah. How to get to know about the prefix. Okay, we can learn a lot of ways to memorize this prefix. Okay, because it can reduce you or it can help you later on. So that is very useful things if you can remember all prefix here. Okay. For example, the real that always we have we can at least know about is tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. Okay. The rest that I have not mentioned is some things is very special. Okay, very special. Kita jarang guna lah. Tapi yang saya tandakan ini yang selalunya kita guna. Okay. Senang je kan macam tu. Saya biasanya kalau hafal tu dengan cara yang lebih. Saya letakkan yang besar di sebelah atas. Tera di sebelah atas dan pico di sebelah bawah. Because tera is 10 power of 12. And pico is 10 power of negative 12. Okay. And that depends on you lah, how macam-macam cara lah. Ada buat lagu dan sebagainya, that doesn't matter. Okay. Okay, anything else? Ada soalan nak tanya sebelum kita masuk kepada dimensional analysis? Ada soalan? About basic quantities and so on? Boleh kita continue?
Boleh. Boleh,
Okay,
sir.
okay, great. Okay, so okay, this is the interesting part. I will learn about the dimensional analysis. So what is dimensional analysis? Okay, so dimensional analysis is is a study about a dimension. Okay, dimension specifically kepada base quantity. Okay, specifically kepada L, M, and T. What is L, M, and T? So L stands for length, M stands for mass, and T stands for time. Length, mass, and time. Okay, if you look carefully, okay, the common things or the common quantity that we can use to do some analysis is mass based on these three things, L, M, and T. Okay, so what is dimensional analysis? Dimension kita faham lah. Ada pengukuran, okay, dimension nak dapatkan dimension, ada boleh uji berat, okay, nak dapatkan dia punya berat dia, dan boleh uji masa, nak ukur masa, okay, uji panjang, uji berat, uji jisim dan uji masa. So that is a dimension. So what about analysis? So in this kind, masuk analysis di sini ialah we want to know, okay, we want to know exact. What is exact? Two things here. Okay, it's either we want to know about yang pertama units. Kita nak tahu apa unit. Like for example, what is the unit for distance? What is the unit for velocity? What is the units of acceleration? What is the units of energy? For example, kalau untuk start satu ni kan, apa unit dia? Apa unit dia? Apa unit dia? If you are answering distance, unit dia L. Betul ke salah? It's wrong. Because L is dia punya dimension. Unit dia apa untuk distance? Unit dia ialah meter. Sebab unit ialah SI unit lah maksud dia. Area. Dekat sini area. Area. Kita tengok area is based on, biasanya kita buat dulu panjang kali lebar. Area. Okay. Area ialah panjang kali lebar. Tapi kalau Melayu ada lebar, ada panjang. Macam mana pula dalam kes ini? Okay. Walaupun nama dia lebar, walaupun nama dia panjang, this both lebar and panjang is considered to be the distance. Okay. Ini panjang dan lebar ni ialah distance. Jadi bila distance, sebab itulah kalau kita tengok di sini, area dia panjang kali lebar tu dia ambil sebagai distance times distance. Maksud dia L kali dengan L. Sebab tu dia dapat L square. Okay. So L square, kalau unit dia senang je sebab L unit dia ialah meter. So kalau L square, unit dia apa dia? M square. So that is the unit for area. And how about volume? Volume is based on length times length times length. Okay, that means L cube. L cube meaning that the units untuk volume, the SI unit for volume will be meter cube. M kuasa 3. Okay, so that's how we get it. Okay, now different. We learn about L, velocity. Velocity is considered to be length over time. Length obviously ialah M unit dia and time unit dia S. Ini senang. What happens when we get to acceleration? So when we do some dimensional analysis, we must first change it or convert it to dimension. Okay, dimension tu daripada mana? Daripada 3 benda ni lah. L, M ataupun T. Dan daripada situ, then you get the SI unit. So let's look at the questions, for example. So macam mana dia katakan dimensional analysis? Okay, yang pertama tadi saya bagi tahu, dimensional analysis is about how you can get the SI unit. Okay. Okay. Benda yang pertama kita boleh dapat daripada dimensional analysis ialah unit. Benda yang kedua, okay, the second thing is here we can get units, number 1. And number 2, okay, if we want to analyze, okay, analyze the correct equation. Kita nak check betul atau tidak equation tersebut. Kita nak check betul atau tidak equation tersebut. Contoh dia. Tengok soalan dia. Problem. Okay. In example 1.1, show that the expression V equals to V0. What is V0? V0 ni ialah initial velocity. Kalau dekat sekolah dulu kita pakai U. Okay. Dekat universiti kita pakai V0. V tu ialah final velocity. O kecil tu maksud dia V0 is the initial velocity plus with A acceleration times time. Okay, so show that the expression V equals to V0 plus AT is dimensionally correct, where V0 represent velocities, A is the acceleration, and T is time interval. Dia dah bagi tahu macam tu. So the problem is we need to show that this expression is correct. Macam mana kita nak show benda ni correct? Cara dia macam ni. So bila kita tengok setiap satu V, for example V ialah V0 plus AT. So how to analyze the correct equations? How to analyze? So cara nak analyze dia ialah kita ada simbol ini. Okay, yang bulat, saya bulatkan tu, this one. Simbol ini maksudnya equation ataupun equal. Okay. Sebelah kiri equations ialah left side and sebelah kanan dinamakan right side. Okay, left side and right side. Okay. So how we can get the correct equations? The correct equation will be if on the right side of the equation is equivalent to left side. Apa maksud equivalent to the left side? Okay, contoh dia, kalau kita gunakan dimensional analysis, kita kena show dia dalam soalan ni dia minta dimensionally correct. So V ialah L over T. Kita dah tahu lah. Macam tu. V is L over T. Jadi macam mana kita nak pastikan yang belah kanan tu betul? Yang belah kanan tu betul bila setiap value V0, value A, value T, value AT tu, okay, setiap equation, setiap apa-apa yang duduk di sebelah kiri mesti sama dengan L over T. Okey, kita cuba kita buat V0 walaupun dia ada not, dia masih lagi velocity. So velocity ialah L over T. So sama tak belah kiri? Sama. Betul? Okey, now kita check di sebelah yang AT pula. So AT ialah acceleration. Acceleration tadi kita tengok apa dia? L over T square. So L over T square. Nak tengok saya buat macam mana L over T square kali dengan T. So T ialah T lah. So T ni mati dengan T ni. So dapat juga L over T. Sama tak dengan belah kiri? Sama. So every item di sebelah kanan, kalau dia sama dengan sebelah kiri, so that means ini ialah dimensionally correct. That is how you state it as dimensionally correct. Dalam dimensional analysis, we can get either to get the SI unit of the answers, okay, or to analyze the SI units, and another one is to check or to analyze the correctness of the equations. How? By comparing to the left side. The left side must be equal. The right side, every item on the right side must be equal to left side. Every item. Okay, tengok persoalan dia kalau saya buat situation yang salah. Okay, contoh dia. V equals to V0 plus AT square. Betul atau salah? Okay, so V ialah apa? V ialah L over T. So maksud dia di sebelah kanan on the right side ni dengan ni mesti kena dapat L over T juga. Okay, so V0 dah dapatlah L over T, so dia betul. Plus dengan A apa? A is L over T square. And T square tu, T square kena T square jugalah. Jadi kalau T square dengan T square, kita potong, tinggal apa? Tinggal L. Betul? Salah. So this equation is not dimensionally correct. Sebab apa? Sebab satu je tak betul. Kalau dua-dua betul, belah dengan belah kiri, we considered as dimensionally correct. So kalau ada berapa item? Kalau ada 4 item, 4 kena betul dengan belah kiri. Tapi bukan dia nak check betul atau salah, dia just memang nak tahu sebelah kiri kena sama dengan sebelah kanan ataupun sebaliknya. Okay. Right. So this is another equation. Tak nampak kat sini, nanti saya bagi dalam bentuk slide nanti baru nampak dalam iPad ni dia bercelaru kat sini. Okay, but we can try on our own. Contoh dia X equals to VT. For example, X equals to VT. Betul ke salah? So X is what? X is a distance. So distance ialah L. Di sebelah kiri L, di sebelah kanan mesti L juga. So kita cuba tengok. Dapat tak L? V is what? V is L over T. And T, okay, and T is still T. So kalau kita potong and potong, kita akan dapat L equals to L. So that means it is a dimensionally correct. Okay. So itulah cara untuk kita proofkan dia. Alright. So for example, kita tukar soalan ni. X equals to okay. Mana soalan dia tadi? Okay. 2x campur, x equals to x naught plus v naught t plus half at. Itu soalan dia. X equals to x naught plus v naught t plus half at. Okay. Macam mana nak buat? Alright. So x, kita buat balik. X is L. Okay, maksud dia sebelah kiri L, sebelah kanan semua kena L lah. So x naught L, okay. V naught t adalah L over t dengan t. Bila kita cancel out, dia dapat L plus L. Yang satu lagi tu, okay. What happens to coefficient yang duduk di hadapan? Bila coefficient yang duduk di hadapan tu, kita boleh ignore saja. Just ignore 1/2 tu. Tak perlu letak kat dalam pengiraan. So, kita turunkan A. A ialah L over T square kali dengan T. Okay. Kita tengok T potong dengan T, so dia dapat L over T. Tak sama. So this equation is not dimensionally correct. Itu yang kita mendapatkan jawapan dia. Kalau dia boleh juga tanya soalan, they can also ask you about what happened to the units. Contoh dia dah bagi tahu. Equation ni dah correct. Dah betul lah correct dia. Okay. But what is the SI unit of B? Dia ada letak. Kononnya dekat tempat V ni dia letak B. Dia letak A. Dia letak objek A. Apa units untuk A? Dia boleh tanya macam tu. Okay. There's a lot of ways to ask you about dimensionally analysis. Dimensional analysis. Okay. Okay. So the uncertainty in measurement and the significant figures. Okay. So these are the rules in to understand about significant figures and the decimal points. Okay. Tengok significant figures. All non-zero digits are considered significant. Contoh dia 1, 2, 3.45 have 5 significant figures. Semua dikira walaupun dia ada point. Because semua ialah bukan kosong. Zeros appearing anywhere between two non-zero digits are significant. Contoh dia, ni kosong yang duduk di tengah-tengah antara nombor yang bukan kosong. So dia pun dikira sebagai full 5. Contoh yang tadi tu semua nombor kira 5. Yang ni kalau ada kosong yang duduk di tengah-tengah nombor yang bukan zero, dia pun dianggap sebagai 5. Maksudnya dalam kes ini ada 101.12 ada 5 significant figures. 13.309 have 5 significant figures. Okay. A leading zeros are not significant. A leading zeros is not significant. Nampak Ni ada leading zeros. Okay, we have a leading zero 0.00052. 0.00052. So that is the leading zeros. Okay, leading zeros has two significant figures. Kenapa dia kata two? Sebab tidak diambil kira kosong yang duduk di hadapan ini. Tidak diambil kira. Okay, so yang dikira hanyalah dua yang di belakang ini. So therefore there are only two significant figures. Okay, how about some trailing zeros? The trailing zeros in a number containing decimal point. Biasanya kita nak tengok benda ni dalam decimal point are significant. Trailing zeros are significant. Kenapa significant? Tengok total. Okay, 1,2.2300 belakang ni is considered has 6 significant figures. Kira semua 1, 2, 3, 4, 5, 6. Okay, we just count every single things when we have a trailing zero, maknanya kosong yang diletakkan di belakang, bukan di tengah-tengah. Kalau di tengah-tengah memang kita kira lah. Okay, kosong yang diletak di belakang has 6. Okay, dan tengok seperti yang kawan sebelah tu 0,0, 0,0, 1, 2, 2, 3, 0,0. Kita again kita tak ambil yang ni. Tapi kita consider yang belakang tu. 1, 2, 2, 3, 0,0 has 6 significant figures. Okay, while 122.00 has 5 significant figures. Okay, has 5 significant figures. Ini untuk case decimal point. Okay, dan case maksudnya nampak ada decimal point walaupun kosong yang belakang tu dia akan mempengaruhi. Okay. Yang last kali ialah the significance of trailing zeros in a number not containing a decimal point. Okay, not containing decimal point ni maksud dia tak ada titik perpuluhan lah, tak ada titik perpuluhan. Contoh dia kalau macam ni 1, 2, 2, 3, 0, 0. Okay, can be ambiguous. Apa maksud can be ambiguous? Ambiguous tu maksud dia boleh kita beri dia dalam jawapan yang berlainan. Okay. Dikatakan 1, 2, 2, 3, 0, has 6 significant figures or 4 significant figures. Dua-dua jawapan betul. Sebab apa? Sebab kita boleh consider 6 sebab dia ialah semua ialah nombor. Satu sebab kalau kita tengok yang di atas ni, okay, semua nombor di belakang trailing zeros akan dikira sebagai full. Akan kira sebagai full. Tetapi again, kalau kita tukarkan dia dalam bentuk, maksud dia 1, 2, 2, 3, 0, kita tukar kepada apa dia panggil? Lupa dah saya. Nombor dalam bentuk kali prefix, dalam bentuk prefix. Okay, 1, 2, 2, 3 kali dengan 100. So kita akan dapat 1, 2, 2, 3. 100 ni adalah 1, 2, 2, 3 times 10 power of 2. So kita pun akan dapat jawapan yang sama dengan ni. So 1, 2, 2, 3 considered to be 4 significant figures. Okay. Any questions so far? Ada soalan? Kenapa kita belajar significant figures atau tak? Okay. So let's look at the calculations here. Kita tengok Several carpet installers make measurements for carpet installations in the different rooms of restaurant, reporting their measurement with inconsistent accuracy, as compiled in table 1.6. Okay, compute the areas. Disuruh cari area for A, the banquet hall, and B, the meeting room, and C, the dining room, taking into account significant figures. Nampak? Dia suruh kita kira ikut significant figures. Okay, and then last kali, what total area of carpet is required for this room? Okay, kita jawab dulu soalan A, B, C, D lah. Okay, so macam mana jawab dia? Dia suruh kita calculate area. Okay, for the significant figures, area, ini kira macam ni Okay, banquet hall, we have 14. Saya ambil banquet hall Banquet hall, we have 14.71. That means how many? 4 significant figures times with 7.46. That means 3 significant figures. 3 significant figures. 3 significant figures. So bila when it times 14.71 and 7.46, okay, kita akan dapat jawapan lebih kurang 109.74. 109.74. Okay, 109.74. Tetapi dalam konsep significant figures, macam mana kita nak calculate? Okay, sebenarnya kalau dalam case significant figures, kita akan pilih significant figures tu yang paling sikit. Okay, contoh dia 4 significant figures dengan 3 significant figures, 3 significant figures. Okay, we will choose the correct answers will be true to 3 significant figures. Kita jawapan akhir dia mesti ikut yang paling sikit, the least significant figures in the question. Itu cara dia, the least significant figures. So kalau kita tengok jawapan akhir dia daripada calculation tu, okay, we will get 109.74. 109.74 is 5 significant figures. Okay, sebab kita calculate semua kan, 5 significant figures. Tetapi dalam konsep significant figures, especially bila area ialah datang daripada multiplication, maksudnya kali multiplication. Okay, multiplication and division, kalau kita encounter problems yang berkaitan dengan multiplication ataupun division, okay, kita akan apply significant figures. Kalau tambah dengan tolak, kita akan apply decimal points. Okay, ingat multiplication and division, kalau macam ni area kan, area kita akan pakai multiplication kali ya, pendarab. So kita akan apply significant figures. Macam mana? We will look at the least significant figures in the question. So contoh dia, length 14.71 ialah 4 dengan width 7.46 ialah 3. So 4 times 3, kita akan ambil 3 significant figures. Tapi jawapan ada 5. Macam mana nak dapat jawapan penuh? Okey, daripada sini kita kena round off dia kepada 3 significant figures. So kalau tengok 3 significant figures, 109. Adakah 109? Kena tengok sebelah dia. Sebelah dia lebih pada 5 kan? Sebelah dia lebih pada 5. So jawapan akhir dia akan jadi 110 meter square. Ataupun dalam kes ini dia nak jawab 1.10 kali 10 kuasa 2 meter square. Kenapa dia tulis 1.10? Kenapa tak tulis 1.1 je? Sebab 1.1 sahaja ialah 2 significant figures. Tapi 1.10 ialah how many? 3 significant figures. Simple. Okay. That's how we did. So kita tengok juga pula untuk meeting room. Contoh meeting room 4.822. So this will give 4 significant figures while the width is 5.1 which is 2. So kita akan ikut berapa? 2 je lah. 2 significant figures. Okay. So 4 sebab dia adalah multiplication kan area. Dapat 24.59. Ini adalah 4 significant figures. We don't want the 4. Okay, we only want 2 sebab soalan dia paling sikit ialah 2 significant figures. So kita ambil yang paling sikit lah. So jawapan akhir dia ialah 25. Okay. 25. Okay. Okay, so for the multiplication and division, okay, we will consider the significant figures. But untuk soalan-soalan yang berbentuk tambah ataupun tolak, okay, kita hanya akan gunakan decimal point. Okay, kita akan ikut decimal point yang paling sikit lah. Okay, but that is the number of decimal places after addition or subtraction is equal to the smallest number of decimal places in any of individual terms. Okay, number of decimal places. Maksudnya kalau macam mana? 16.74 berapa decimal places dia? 2 decimal places. Kita ambil nombor perpuluhan di belakang. Yang ni apa? 1. Yang ni ada berapa? 1. Yang ni ada berapa? 2. So we take at least 1 decimal places. Untuk soalan macam mana? Soalan yang berbentuk addition or subtraction. Okay, and then the last part ialah scientific notation. Ini awak dah biasa kan buat scientific notation 2500 kita jadikan dia dalam bentuk 2.5 10 power of 3. Sebab dia kali 1000 kan. If we write it down as 2.5 times power 3, it has 3 significant figures. 3 significant figures. Okay, so I think we'll take a break first. We will continue later. We take a 5 minutes break. Okay, kalau ada masalah boleh chat, boleh tuliskan kat chat. Ataupun ada soalan ke nak tanya apa-apa? So kita akan break dulu dalam 5 minutes. Okay, maybe you want to stretch out apa yang dah ni before we continue. Okay. Okay, ada soalan? You have questions? Boleh faham eh? Boleh saya tahu apa kelas rep untuk 57? S57? Apa kelas rep untuk S57? Kelas? S58?
Danish.
Okay, so let's continue our lessons on the conversions of units. Okay, conversions of unit. All right. So basically, in the conversions of unit, I believe that all of you have already learned during your school days. So of course, in modern maths, I believe we have a conversions of units. Okay, pertukaran unit. Cuma pertukaran unit di peringkat sekolah atau di peringkat universiti lebih kurang sama saja. Ada orang boleh buat shortcut, ada orang tak faham, ada orang yang dia boleh buat lama lah, tapi dia boleh buat guna calculator je, selesai. Okay, ada banyak cara masing-masing ada cara nak buat lah. Okay, but in the end, the correct way to do conversions of units, okay, for example, you need at least to know the how we convert the units, especially conversions between centimeters to meter. That is simple. Okay, this is something related to miles. For example, the question gives you in miles, in miles per hour, in the system of miles per hour. So you need to convert it to SI unit. You need to convert it to meter per second, for example. So how to do it? Okay, so these questions, okay, these examples, okay, all examples, if you take note, especially in my lecture, the examples 1.4 is taken from the textbook. Okay, every examples in my lecture notes is basically taken from the textbook. Okay, so if a car is traveling at a speed of 28 meters per second, is the driver exceeding the speed limit of 55 miles per hour? So you need to know the conversion between how to convert from meter per second to convert it to miles per hour. Okay, miles, miles per hour. Okay, meter per second, you need to convert it to miles per hour, right? So how to do that? You need to know a very good way of, a very good approach in terms of unit conversions. Okay, whatever happens, cara kita nak mematikan satu-satu value, okay, atau we want to cancel out the value or the units, you must make sure that the units, if you wish to cancel out each other, must be let's say the equations ataupun unit tu saya letakkan dalam bentuk macam ni, M per S, miles per hour. Satu di atas, satu di bawah. Satu di atas, satu di bawah. Walaupun dalam tulisan dia bagi M per S macam ni, Yang ni miles per hour. Kadang-kadang dia tulis ms -1, yang ni dia tulis mih -1. Okay. So we need to think that way. Maksud dia every possible way yang berkaitan dengan conversion. Kalau setakat conversion yang mudah, contoh dia 1000 meter sama dengan berapa kilometer. Itu biasa. Okay, itu satu level saja, satu layer. Yang ini melibatkan dua layer. Because we want to convert it from meter to miles. Okay, sebab meter tu length, unit dia length. Miles unit dia dalam length juga, tetapi dalam bentuk miles. Okay, and the second ialah time. Hour pun ialah time. Jadi dia takkanlah meter tiba-tiba dia jadi hour, tak boleh. Okay, it's unlogical. Okay, so you need to think that every yang berkaitan dengan macam ni kita kena buat satu per satu. Maksud dia, for example, okay, now we have 28 meter per second. You put 28 like that, meter per second. Okay, so in order to get miles, nanti kita ada conversion dia. Kalau kita tengok dekat situ, 1 mile is equivalent to 1609 meters. 1609 meters, okay. So ada conversion miles dengan meter ni. Okay, tapi kadang-kadang kita lupa atau kita tak ingat lah. So untuk dapatkan value ini, 1 mile is equals to 1609 meters, kadang-kadang kita memerlukan our calculator. Kan, at the back of the calculator tu ada conversion ni kan. Tapi kadang-kadang ada dewan exam yang minta back calculator tu dibuang, diletakkan di tempat lain. Tu depends lah dia nak nasi-nasi awal lah. So kalau macam tu kita tak boleh nak tolong apalah. But in my case, kalau saya jumpa calculator yang dekat belakang dia tu ada calculator, apa dia punya cover calculator tu kan. So tak ada masalah pun. Okay, because it helps you to answer this question properly. At least kita tak perlu pun hafal 1 miles equals to berapa meter. Tapi at least kita tahu macam mana nak convert miles to meter. That is the most important thing. Rather than nak kena hafal benda-benda ni. Okay, because here we didn't train you to memorize. We train you to understand the problem and you can answer every questions from that. That's why the approach is different. Bukannya nak memorize. Alright. So 28 meter per second. Ya, M ialah meter. Nampak unit dia mesti betul lah. Meter per second. Jangan meter apa tulis MI pula. Then awak akan confuse. Okay, so meter di atas. Sekarang meter kita nak buang. Kita nak ganti dengan miles. Okay. Tapi meter mestilah dipotong dahulu. Mesti dibuang dahulu. So kita kena kali dengan every yang conversion yang berkaitan dengan meter. Tapi meter ni perlu letak di mana? Dia perlu letakkan di bawah. So 1069. Yang ni saya dapat daripada calculator meter. Sebab apa? Sebab kita nak cancel out meter tu is equivalent to 1 miles. So kalau kita tengok meter di sini akan dipotong dengan bawah. Meter tak boleh dipotong dengan side dia. Dia tak boleh potong dengan atas tak boleh. Ya, atas kena potong dengan bawah. Okay. Now you have miles, but how about seconds? Jawapan di sini ialah nanti seconds duduk di sebelah bawah. So kita tak nak dia duduk sebelah bawah, dia nak duduk di sebelah atas. So kita akan buat 3600 seconds equals to 1 hour. That is the conversion. So that you can cancel out seconds and second di sebelah atas. Dapatlah jawapan akhir dia dalam. So jawapan dia akhir dia nanti ialah 28 times 3600 times 1 mile over 1609 times 1 hour. Dapatlah dalam bentuk miles per hour. Jadi jawapan dia nanti 62.6 miles per hour. Adakah dia telah menjawab soalan ni? Memang dia dah jawab, tapi tengok soalan dia sebenar. The question asks you, is the driver exceeding the speed limit of 55 miles per hour? Jadi kalau awak tak jawab tu, awak dah hilang satu markah dekat situ. You lost 1 mark because you didn't answer. Does the driver exceed or not exceed? Okay, of course dia dah exceed dia punya speed limit. So kena jawablah yes. Okay, the driver have exceed the speed limit because the value of the conversions of 28 meter per second is equivalent to 62.6 mile per hour. Okay. Okay. A Porsche sports car can accelerate at 14 meter per second square. Determine its acceleration in kilometer per hour square. How about calculations about when we do have power? Bila ada calculation yang melibatkan power, dia akan jadi macam mana pula? Again, okay, sebenarnya cara dia pun senang saja. Ada pula ini. Okay. Okay. Tengok macam mana nak convert ke 14 meter. Tadi meter per second kan, ini meter per second square. Dia ada square dekat luar tu. Dia tak sama square ni sebab dia ada dua square. Dia ada S, dia ada S. Dan kebetulan yang dia nak ditukarkan tu nanti kepada kilometer per hour square. Jadi kita dah tahu dah, meter akan convert kepada kilometer and second square kena convert kepada hour square. So hopefully square dia tu akan ada signifikan lah, maksudnya square dia tu akan maintain je macam tu. Tapi ada orang selalu buat salah dia macam ni nanti dia confuse. Yang ni hour square ni ada setengah nanti dia pening. Okay, so macam mana nak buat? So 14 meter per second square, yang pertama sekali kita akan matikan meter dulu, okay, kepada kilometer. So 1000 meters equivalent to 1 kilometer. Sebab apa? Sebab we want to cancel out meters and we leave with the kilometers. Okay, how about second square? Yang ni penting. Kalau saya akan buat macam ni square tu saya letak di luar. Sorry, semua square saya letak di luar. Okay, so 1 hour is equivalent to 3600 second. Conversion di dalam masih sama, 1 hour 3600, tapi ada second, ada square dekat luar, jangan lupa. So bila kita cancel out, kita akan cancel out meter with meters, second square akan potong dengan ini sahaja. Square tu, kalau jangan lupa konsep dia A, B square. Kalau macam ni, maksud dia A square, B square. Orang yang selalu salah ialah bila dia 3600 tu dia tak square kan. Dia lupa. So, dia akan jawapan dia macam mana? Macam ni. 14 times 1 kilometer times 3600 square. Sorry. $3600 square. Lepas tu S dah square dah hilang lah. Dia dah square over 1000 times 1 hour square hour. Satu square, hour pun square. Then we will get the value. Yang selalu jadi masalah ialah dekat sini. Orang lupa about 3600 square. Sebab dalam bracket bila kita square, kita kena square dua-dua sekali. Alright. Okay, so you get the answers. So in the question, the examples is how many $1 bills stacked on top of the other will reach the moon. So macam mana $10 bills? Nampaklah ada banyak soalan yang melibatkan penukaran equation, tapi dia menggunakan konsep approximation. Approximation tu adalah contoh dia $10 bills will be equivalent to 1 millimeter. Itu dia punya approximation. Approximation dia So dia calculate lah some calculations and then kita akan dapat 4 times 10 power of 12 bills. Mana answer. Okay, so let's continue. Tiba-tiba dah masuk chapter 3. Because chapter 3 ni dia ajar terlebih dahulu bersama chapter 1. Okay, in this week, if you look at the lesson plan, there are chapter 1 and chapter 3. Chapter 2, yes, after this. Because chapter 2 is the motion. Motion, maksudnya minggu berikutnya. Nanti baru kita akan belajar motion. Okay, sebab motion ada 1 dimension and 2 dimension. Chapter 2, 1 dimension. Chapter 4, 2 dimensions. Okay. So that's why kita belajar motion tu kemudian untuk chapter 2. So that's why dia loncat terus kepada chapter 3. Okay. If you look at chapter 3, we will learn about vectors and their properties, components of vectors, and scalar or dot product, and also vector or cross product. Okay. Alright. So what is this all about? Ni kita nak belajar vector lah. Okay. So vector and scalar. Okay. So vector and their properties, right? So we do have a scalars and vectors quantity. Okay. So a scalar quantity has only have magnitude. Dia ada magnitude saja. While vector quantity has both magnitude and direction. Itu beza antara scalar and vector quantity. So you can see, okay, a lot of dimensions, a lot of parameters in scalar and vector quantity. So be familiar with the quantities. Bukan suruh hafal pun, tapi be familiar kan. Benda-benda yang pelik-pelik. Macam contoh dia momentum. Dia duduk di vector quantity. Kenapa? Nanti kita belajar momentum, kita faham. Acceleration, why it puts under vector quantities. So speed, speed kenapa duduk kat scalar? Kalau tengok kawan speed adalah velocity, dia duduk dekat vector quantity. Kenapa speed tu kan kalau kita tengok ialah length over time. Length over time we get speed. And length over time we also get velocity. What is the difference between velocity and scalar? Velocity and speed. Laju dan halaju. Kalau Melayu laju dan halaju. What is the difference? Okay, so itu kita kena tengok betul-betul. Alright, the temperature will be scalar quantity, force, okay, will be a vector quantity, work power, scalar again, and then lastly, thrust weight. Okay. So vector is represented by an arrow. If you look at the value or the arrow, okay, arrow parallel to the horizontal is often represented by, maksudnya dia represent vector. Okay, the magnitude of vector will be represented by italic. Kadang-kadang dia guna italic. Okay, contoh dia A. Ni dia buat gelap lah, kali dia gelap sikit. A tapi dia berbentuk italic. Okay, ada juga A yang ditandakan di atas macam ada topi. Tu A macam tu juga. So that is also vector. Senang cerita bila kita when we talk about vector, there must be a scalar, it must be have magnitude and directions. While the scalar quantity only have vector magnitude only. Okay. Okay. Okay, you look at the equality of two vectors. Okay. Two vectors are equal if they have same magnitude and same direction. Itu equality dia. Maksud dia kalau dia sama panjang, kalau kita tengok sama panjang, arah yang sama, so maksud dia there is a two different or two equal vectors. So basically kalau kita cerita bahasa kita, what is vector? Vector ni apa ni? Pengukuran lah. Tapi pengukuran yang ada direction. Pengukuran yang ada arah. Kalau cakap berapa panjang dia? 10 meter. 10 meter bukan kira vektor. 10 meter is still scalar quantity. Tapi 10 meter ke kanan, then it will become vector. 10 meter ke utara, 10 meter ke selatan, then it become vector quantity. That is the difference between how you can state the value. Okay, kenapa kita belajar benda-benda ni? Sebab kita nak tahu lah macam mana bila kita nak jawab nanti bila minta dalam vector quantity macam mana, scalar quantity macam mana. Okay. So in the vectors, okay, we can add it graphically. Okay, kita boleh tambah vectors. Of course, vector is still have magnitude. Ada magnitude kan? Because of that magnitude, vector can be added. Ya, yang pertama menggunakan secara graphical, gunakan secara lukisan. Contoh dia, ini dinamakan tip to tail method. Tip to tail method. Contoh, we have vector A and vector B. Okay. So the R will be the resultant vector. R ialah resultant vector. Okay. R means resultant vector. Okay. So vector A is maybe due to is, vector B may be due to northeast, kan? Satu tunjuk ke arah timur, B tunjuk ke arah timur, northeast kan, antara timur dengan utara. So dapatlah resultant dia. Maksud dia yang pertama kita buat A dulu, vector A, kita lukis vector A. When you draw a vector, you must use the correct. Bila nak buat secara graphical, bila nak gunakan kaedah graphical, so you need to measure correctly. You need to measure correctly the vectors. Okay, when you add the vectors, okay, when you draw a vectors, you must draw in a standard unit. Mesti gunakan units yang betul. Maksudnya kena ukur berapa, kena ada perkadaran dia. Contoh dia, when you draw a vector, let's say dia cakap arah A, arah vector A itu ialah 20 km. Oh, 20 km. So 20 km ni maybe kita kena lukis lah 1 cm sama dengan 5 km. So kita kena state down. State to 1 cm 5 km. Dan bila kita dapat lukisan ni. Okay, kena lukis dengan betul. Maksud dia kalau dia minta parallel ke arah east, maksudnya dia parallel dengan horizontal lah kan. Dia parallel dengan horizontal. Okay, so bila nak lukis B pula, dia kena ada angle dia, berapa jarak dia daripada horizontal, berapa panjang dia. So everything must be precise, must be accurate when we want to add the vector graphical. Okay, this one, contoh lain ialah resultant vector for vector more than 2. So normally we only have 2 vectors. Nampak ada A campur B, R equals to A campur B. Tapi tiba-tiba ada banyak vektor yang lain. Then this is the right methods to do. So you can add vector A plus vector B. At the end of vector B, you put vector C. Jadi sebenarnya kalau kita lukis vektor secara grafikal, kita buat seolah-olah kita buat macam ni. Saya padamkan tu. Selepas kita buat pengukuran, okay, when we do some ratio, okay, when we do some ratio, and then we draw it carefully. Okay, let's say the vector A is pointing towards east or towards west, it doesn't matter, towards east. And then at the end of vector A, we need to draw a crest like this. Okay, kita draw lebih kurang macam seolah-olah ada kompas kat situ. So daripada sini kita ukur berapa pula jarak dia, berapa pula dia punya angle dia daripada horizontal. Then we draw vector B. So kalau contoh dia, kalau kita ada more than 2 vectors, bila kita ada more than 2 vectors, okay, dekat ujung vector B tu kita buat vector C. Kat ujung vector C kita buat vector A, vector D. And then last kali nak sambungkan daripada awal vector A kepada hujung vector B. Awal vector A kepada hujung vector B. That is tip to tail method. This is cara nak menggunakan graphical. Bila dia mention graphical, maksud dia awak kena lukis, you need to draw a precise and accurate value. Mesti kena gunakan ratio yang betul. Kena guna pembaris. If can, you need to use a protractor. Okay, kena guna jangka sudut untuk kita lukis correct way. Sebab tu kita gunakan cara yang lebih detail. Sebab lukisan itu nanti at the end, macam mana nak dapatkan magnitude dia? Magnitude resultant ini kita ambil pembaris kira. Okay? Ambil pembaris kira. Berapa jarak dia? So, kita gunakan ratio kita. So, the resultant vector will be sekian value. Berapa dia punya angle? Tengoklah angle daripada awal tadi. So, itulah kita dapat dia punya direction untuk graphical methods. Okay, alright. So, let's look at this example. Okay, kalau kita tak perasan tu dekat sini, we have vector A and vector B. It's stated here that vector A is 5 meters. Okay, vector A is 5 meters, 60 degree above the x-axis. Tengok macam mana. Now we have x-axis, we have y-axis. Ini nampak cara dia nak lukis. So first, dia kena buat vector A, ambil pembaris. Kalau kertas kita cukup luas nak lukis, takkan kita nak lukis 5 meter. Atas kertas, tak logik. Okay, so we can represent 1 centimeter is equivalent to 1 meter. So kita boleh lukis kat sini berapa? 5 centimeters. Okay. Okay, and then how about vector? Vector A tak susah lagi. 60 degree above x-axis. 60 degree above x-axis. Sebenarnya ada tulis x-axis. Sebab itulah kita akan dapat di sini. This is x-axis, 60 degree above x-axis. Okay, and then B will be 4 meters, 20 degree above x-axis. Again, x-axis kat sini ya. Macam mana dia buat? Dekat sini, nampak? Kita buat macam seolah-olah ada another compass. Kat situ. Okay, ini imaginary saja, imaginary je. But dalam in reality kita boleh buat lah. Okay, so kita anggap ini sebagai x-axis. So 20 degree. Okay, dan kita pun lukis dia ikut panjang yang kita dah gunakan ratio dia, which is 4 meters. 4 meter sama dengan 4 cm lah. And then ada dua je kan. So A plus B. Vector A plus vector B, kita akan dapat resultant dia. We'll get the resultant. So the resultant kita ambil daripada awal vector A ke akhir vector B, ukur. And kita dapatkan dia punya angle. Okay, so angle ini ialah dinamakan direction. So magnitude daripada mana? Daripada lukisan kita, which is panjang, sepanjang-panjangnya C tu. So angle itu ialah dikira sebagai directions. So using ruler and protractor. Okay, bila using ruler kita dapat 8.75. Panjang dia. Jadi kita tahulah 8.75 ni ialah dia punya magnitude. And how about dia punya protractor tu buat apa? Dapatlah 45 degree. 45 degree tu ialah 45 darjah above the x-axis. So that is the complete answer for vectors problem. So sebenarnya vektor ni, sebenarnya inilah cara yang paling sesuai dikira. Okay, bila kita gunakan ruler, protractor, kita kira yang mana satu dah betul. Okay, but tidak semudah itu. Tidak semudah itu bila kita nak calculate vectors. Sebenarnya ada cara yang lebih sesuai untuk calculate dia, which is menggunakan konsep calculations. Nak gunakan konsep calculations lah. So macam mana kita tengok? Sebelum kita nak tengok tu, kita tengok dulu the sum of vectors is independent of the other in which the vectors are added. Contoh dia, A campur B, vector A campur vector B adalah sama dengan vector B campur vector A. Okay, kenapa kita kata vector B campur vector A? Sebab dia start di hujung sini. Okay, dia pergi, dia buat, dan di hujung situ vector A pun buat dia punya. Sama jawapan dia kalau kita tengok betul-betul. Ini ialah R. Okay, dan yang ini ialah R untuk soalan ini. Jadi kalau kita tengok dua-dua panjang ini adalah sama lebih kurang. Okay, because A plus B will be equivalent to B plus A. Okay. And then how about the subtracting vectors graphically? Subtracting ni a bit dia sebenarnya subtracting ni ialah berasal daripada addition ni. Contoh, vector A is like this, like that. Okay, going to the east. Kalau kita buat negative vector A, dia ialah panjang yang sama tetapi arah yang berlawanan. Panjang yang sama tetapi arah yang berlawanan. Sebab tu dikatakan, if kita nak tambah, kita akan buat what is A, vector A tolak vector B. A tolak B bersamaan dengan apa? Vector A plus negatif B. Itu maksud dia. Dia sama A tolak B tu ialah A campur dengan negatif B. Apa maksud negatif B? Saya dah terangkan tadi kan. Ni. Dia benda yang sama. Tetapi pada arah yang berlawanan. Panjang sama. Contoh dia panjang B dekat atas ni 5 cm. Bawah pun mesti negatif 5 cm. Panjang ni mesti sama. And then baru kita ambil dia punya value dia. R sebagai R. Okay. So, okay. Find the sum of two vectors by using a graph. A graph paper is also one method to use, or one method that we can use, or one approach. We can have a better better solution in order to get the right answers. Okay, kita guna kertas graph. A car travels to 20 km due north. 20 km, takkan nak lukis 20 km, so we need to justify with the ratios. Okay, so 1 cm equivalent to 20 km, 1 kilometer. Ataupun mana-mana lah, tak kisahlah, yang penting kita muat dengan kita punya jalan kerja. So, and then 35 km in the directions of 60 degree west of north. 60 degree west of north. Jadi kita nak ambil daripada west atau daripada north, 60 ni daripada north. Sebab itulah kalau kita tengok angle of B tu. Okay, maksudnya kalau saya buat dekat sini, ni je. Maksud dia angle itu bukan angle dekat X axis tapi angle dengan Y axis. Kenapa? Sebab Y dah jadi north. Kalau nak tahu west of north tu kita baca daripada mana? Kita baca dari macam ni. Kembali dia, kita baca daripada north kepada west, north kepada west. Nanti saya akan terangkan lagi mungkin awak susah nak faham west of north, okay, west of east kan. Nak baca daripada mana dulu? Daripada east dulu ke atau daripada west dulu? So using a graph, find the magnitude and direction of single vector that gives the net effect to the cars. This vector is called the cars resultant displacement. Okay. So mudah saja untuk menyelesaikan masalah ini. Any questions so far? Ada soalan tak? Besok kita akan tengok sikit lagi mengenai vectors. Okay, and then the vector dot product and cross product. Okay, ada soalan lagi tak? Ada soalan? Tak ada?
Tak ada.
Okay.